This is part 4 of the centroid, about the centroid on the Cartesian plane. If you'll download the worksheet from my website, the exercise can easily be done. It makes it clear and easy to understand. We'll start with task 1 on the worksheet, which is to simply name the vertices of the triangle. And there they are. Now we use this formula to find the centroid. Adding the x's, we get 3 over 3, and the y's, negative 3 over 3, which gives us 1, negative 1. So the centroid is at 1, negative 1. Now what's important to note here is that we haven't needed to know the medians. We've just worked it out from the vertices. We're going to draw the medians anyway. And in this particular triangle, it's very easy just by inspection to see where those medians belong, because the midpoints are so easy to find. There's the first one, there's the second, and there's the third. And we see from the drawing, indeed, the centroid is at 1, negative 1. That was task 2. Task 3, let's check if all the small triangles have equal area. So there's the first. We're going to use half base times height. Well, the base is 3, the height is 4, so that's 6. The next one is the same. The base is 3, the height is 4, the area is 6. Now with this one, I can't find an integer base. So there's a trick you can do on the Cartesian plane, and it's this. Now it's 16 minus 2 minus 4 minus 4, and the answer is 6. Here is the next one. Well, that has a base of 6, a height of 2. The area is 6. This one has a base of 6, a height of 2, area 6. Again, this last one is not so obvious. We'll use that trick again. 20 minus 5 minus 8 minus 1, and the answer is 6. So we've proved that the areas of the 6 small triangles formed by the medians in this triangle are equal. For a proper proof of this, see part 2 in this series. Now we go over to page 2 of the worksheet and task 4. On this page, I'm going to give you 3 lines which intersect. Can we find triangles that have the line's intersection as their centroid and segments from the lines as their medians? Here are those equations. Let's first of all graph them. There's the first one, there's the second, and there's the third. They look like they intersect at 1, negative 1/3, but we need to make sure of that, and the way to do that is to solve these equations simultaneously. The intersection method would be the easiest because all the equations equal y. If we let equation 2 equal equation 3, we get x equals 1. Now if we substitute that back into equation 1, we get y equals negative 1/3. So the lines intersect at 1, negative 1/3. Back to our graph. Can we find triangles that have this point as centroid and segments of the lines as medians. You might want to stop the video and try and do that. But here is one such triangle. Are there other triangles? Well, there is another. And the interesting thing about this triangle is, if we compare it to the first triangle, it's the medial triangle of the first triangle. An important thing to note here, a triangle and its medial triangle have the same centroid. Are there other triangles? Yes, this is another. And this is another one. And this is yet another. In fact, there are an infinite number of triangles with this centroid and segments of the lines given. But that is not true for any three intersecting lines. Alright, that's all for this video. I hope you found that interesting. This is the end of the fourth video on the centroid. You'll find more hands-on maths on my website and on my YouTube channel. Thank you for watching.